As we wrap up this section on law of sines, there's one more idea that I want to cover with you, and that would be finding the area of a triangle, not a right triangle. So what if I asked you to find the area of this triangle? How do we do that? Well, you learned from geometry that the area of the triangle is 1/2 times the base times the height. Okay, but in this picture, we don't have the height of the triangle. So, and we could consider any of the sides as the base if we just rotate it around. But let's say I let A be the base of the triangle. Then the height of the triangle is going to be there. Let's call that H. So how do I find the height of that triangle? Well, if I use this angle C and use my right triangle trigonometry, I do know that H, let's write it over, let's write a different color, how about green? I know here that H is equal to B times the sine of C. If that goes too quickly for it, think of it this way. What's the sine of angle C? It equals the opposite leg, which is H, over the hypotenuse, which is B, and then I just multiplied the B to the other side. All right, so the height is B times the side B times the sine of angle C. So if I replace that in my calculation over here, the area is going to be 1/2 times the base, which is, the base in this case, in this picture, is A, times H, which I just figured out is side B, times the sine of angle C. And so without actually finding the height of the triangle, I can get the area of this triangle. Let me get an arrow pointing here. If I have two of the sides and the angle that's between those two sides, it's just going to be 1/2 those two sides multiplied together times the sine of the angle between them. Now, what if I had chosen a different side as the base? Well, it would still hold. So for example, if I did the altitude from B down to side AC, then that would be my height. And so then the B would be my base, so 1/2 times the base times the height. But in terms of angle A, the sine of angle A is H over C, so H is equal to C times the sine of A. So we're noticing a pattern here. So in that case, if I had sides B and C, here's side B, here's side C, and I knew the angle between those two sides, in this case it would be angle A, then I could get the area by doing 1/2 B times C times the sine of angle A. So as long as you have two sides and the angle between them, the area of any triangle is 1/2 A times B times the sine of angle C. And it's just important to understand that A, B, and angle C, these don't really matter in your picture. It just matters that you have two sides and that the angle you have is between those two sides. So let's take a look at an example. Find the area of this triangle. All right, you might want to hit pause, try and calculate it, and then compare your answer. All right, first thing I notice is I do have two sides, and I do have the angle between them. So the area should equal 1/2 the two sides multiplied together, 90 times 52, times the sine of the angle between them. And then we'll grab a calculator and we'll punch that in. 0.5 times 90 times 52 times the sine. Make sure you're in degree mode. 102. I think I'm in degree mode, yep. And that gives me 2,288.87. Didn't say where to round it, so let's go 2 decimals. 2288.87. 2288.87. And this had units on our sides, so that would be square meters or meters squared. And I noticed that's an approximation because I had a round, it's not an exact, but it's pretty darn close. So that's it. Now, I know what you're thinking. Well, wait a minute though. In this triangle, the altitude, if 90 is my base, is actually outside of the triangle. The height there is outside of the triangle. And I'm going to move the 52 right there. So how do I figure out the height? Well, I'm not going to use the 102. I need to use this angle here. And what's that angle? Well, we know a straight line measures 180 degrees. So if I subtract 102 from 180, the supplement is 78. So this angle here is 78 degrees. So to find h, the sine of 78 degrees is equal to h over 52. And then I'll multiply the 52 to the other side. And h is equal to sine of 78 times 52. Here I had the sine of 102 times 52. But wait, we do know that when we were looking at our unit circle in the last unit, that angles in our, if we have an angle here of 78 degrees, that corresponds with this angle in the second quadrant of 102 degrees, because both of them are 78 degrees up from the x-axis. So the sine of 78 equals the sine of 102. So therefore, we don't have to worry about the case where we have an obtuse triangle. It's still going to work out correctly with our formula that we just derived.